Charles Ramirez, owner of NVS Audio in Roselle, New Jersey and Daytona, Florida. So I've been waiting to make this video for a while. I've had these destroyed lithium batteries for a couple of years now. I knew I was going to need them for a video, and it was just the right time since this whole week we've been doing videos on lithium batteries. So I covered up the brand because I have a destroyed battery from every single manufacturer and it's never the battery's fault. So if you could see how melted these batteries are, and if you could see how destroyed these are, both these batteries were destroyed by improper charging. So that's why here at the shop we always recommend using the battery charger that's made by the manufacturer. So if we sell limitless battery, we sell limitless charger, we sell braille battery, we sell a braille charger. So we try to always match the battery with the charger because the company that designed the battery designed the charger. Plus, the number one question they're going to ask you when a battery fails is what charger did you use, because they're trying to put the blame on you and take the blame off themselves. So if you have the matching charger on the receipt as the battery, they know you used the proper charger. It lessens the ability for the company to take away your warranty. Plus, it's just safer that way. We see with both these batteries, the client used what they thought was the appropriate charger and it wasn't. So one of these batteries was actually destroyed by one of my employees, Gio. I asked him to grab the lithium charger, set it for 2 amps, 20 minutes. He grabbed the lead acid battery charger and set it for 200 amp, 2 hours. The battery literally caught fire and we had to evacuate the shop. Chris was there with me for that. Thank you, Gio. And it was an experience. So it smelled so bad that we couldn't go back in the shop for at least an hour. And I have a pretty big shop. The shop in New Jersey is 10,000 square feet. So one battery was able to fill the building with so much poisonous gas that we had to clear out the building and could not walk in for at least an hour. So you gotta be careful with these batteries. But I have never ever seen a battery explode or deform like these two batteries have unless they were improperly charged. So you're not supposed to jumpstart these batteries. You're not supposed to, if they won't take a charge, you're not supposed to force them to charge. So what's different about these chargers than a standard charger is a standard charger is going to apply voltage no matter what. Lead acid battery, you hit it with 20 amps, 15 amps, it forces the battery to charge. You can't do that with lithium battery. So some of them have BMSs where the BMS will actually detach. So you could send as much voltage as you want until that BMS reattaches. The battery terminals, you're not going to get any voltage into the battery. So then biggest mistake some people make is they'll jump start the bike and then ride it and think that it's good. No, you're actually riding off the stator and causing damage to the stator because trust me, that battery's still disconnected. If you were to shut the bike off and turn it back on, it would not turn back on. So what these chargers do differently is they have a pulse or a repair mode. So if you hit this button on the lithium charger, there's different modes. If you hit this button on the braille charger, it's got different modes. So what it does is it slowly pulses the battery at low voltage and it keeps pulsing the battery until it slowly brings the battery back up. And once the battery goes above 9 volts, then it'll kick into regular charging mode. So what I do is I have clients get a jumper pack, but you can't have one of those jumper packs that automatically times out and turns off. So I'll hook a jumper pack up and leave it, or I'll connect it to another battery and leave it. Do not start it, do not attempt to charge it. If you have the two batteries connected together, it will steal power from one battery and it'll go to the battery that's dead where the cells have been depleted. Once you let both those batteries even out, then you can plug in a charger, then the battery will start charging. That is the safest way to do it. If you're stuck on the side of the road and you don't want to pay for a tow to get home, they tell you not to jump the battery, which I agree with. But if you have a battery pack, and you connect to both batteries and do not try and start the bike, the batteries will level out eventually, then the battery will accept the charge. You're not supposed to jump lithium batteries because if you jump it and start the bike, the battery, you're either forcing it to take a charge when it doesn't want to because the voltage is too low, or the battery just never connects and you're riding the entire way home on the stator. So if you connect the two batteries together and let the battery steal from the other battery until the voltage is even out, then you're able to charge it, then you're able to start the bike. Easiest, safest way to test to see if the battery's taking a charge after you've done this is turn the bike off after it starts, And if it starts back up, the battery has a charge in it. If it doesn't do anything, that battery's still disconnected, and you shouldn't ride the bike. So it's very important to use the proper charger with the proper battery. Both these batteries are destroyed by improper charging. Another thing I want people to realize is just because batteries are the same size, so you know, this is a 30 case and this is a 30 case, which is Harley size, but looking at the batteries from the outside, you'd swear they're the same size. That has nothing to do with the capacity of the battery. So if you look at this battery and you could tell, you could see the case, you're assuming that the battery has cells from here to here. It does not. The actual battery is only filled up to here. So there's nothing in the top part of this battery. So including this part and the part of the case, you could fit another 1/3 of cells in the battery. It's not a good or a bad thing. It's just you can't judge the battery size. It's not like a lead acid battery. If you have a big lead acid battery, you have a high current battery. In these batteries, I've seen, like the NOCO battery, for example, is literally this same size case, but it's an 8 amp hour battery, which is 1/4 of the strength of this battery. So it's not good or bad. It's not false advertisement. They actually say that it's an 8 amp hour battery. It's stronger than the factory battery, but not as strong as one of these audio batteries, and it's only $200. The reason it's $200, it's literally 1/4 of the capacitance of this battery. So if you look inside in the cells do not take up the entire case. They give you that case to make it fit the underseat Harley location, so they make it the same group size. But as far as capacity, the inside of the battery is only 1/3 of the way full, because that's all it needs to make 8 amp hours. So inside lithium batteries is a pack of cylinders like this. Well, obviously not like this. This is burnt. This is what happens when you blow a battery up. But it's a cluster of cylinders. This battery has 4 of these clusters. This battery is filled to the very top. With cylinders. This is very, very high capacity battery, but that's what happens when you don't charge it properly. That battery caught fire on a slingshot. Client was using one of those big X-side power with the wheels that he uses for his big truck. And he thought it would be a good idea to connect it to the slingshot. And next thing he knows, there's smoke coming from the back end and it's boiling. You cannot charge lithium batteries on non-lithium chargers. That's what happens, especially on high amperage chargers. So this is the block of lithium cells inside this battery. Each one of these cells is 3.3 volts. So 4 of them in series create 13 volts. And then, so there's 4 series cells, and then they're wired together in series 4 packs to create this battery. So if you only took 4 of these cells, you would still have 13 volts, but you wouldn't have the amperage. So to get the amperage, they're all coupled together in series parallel to create the same 13 volts with much higher amperage. That's the way all of these batteries work. If you cut any of these batteries apart, you're left with small batteries that look like small type D regular batteries. They're all hooked up in series parallel, and that's how these batteries, okay, it's no different than your drill batteries for your Makitas and your DeWalts. It's all the same technology. So the difference between this battery pack and a DeWalt battery pack is because the DeWalt's 18 volt and these are 13 volt. It's just how they're series parallel together, and there's only one group of packs. So it would take 4 of these battery cells to power one DeWalt. That same voltage will actually start the car. If your battery's not low, you can jump start your car with a drill battery, right, Josh? So that's because you don't need all the amperage, but it has the proper voltage. Now, these are big audio batteries, so the 3 or 4 cells together would give them the voltage. All these other additional packs give them the amperage. So don't let the outside casing fool you. That has nothing to do with what's inside the battery. The reason you will never see a 10,000 watt underseat Harley battery, well, not at least in the next few years, is because this many cells will not fit in a case this size. So obviously this battery is a lot stronger than this battery, but these cells will not fit in this battery. That's why most of your high power Harley batteries will be 4,000 or 5,000 watts, because you physically can't fit bigger cells in the battery. The math is what it is. So you're limited to this side case, and you're limited to about 30 amp hours, and you're limited to about 5,000 watts. Is about as much power as you're getting, just because of the size restriction of the Harley battery case, if you want it to fit under your seat. That's why a lot of the competition guys are doing like 150 amp hour or 100 amp hour under the tail. It's literally 2 or 3 of these batteries combined in one case. So if you're doing a big competition bike that has big tail section, they'll do one of these under the seat, then they'll do a giant battery in the tail. When you mix batteries, you have to make sure that the chemistry is the same. That way it can be charged with one charger. It just causes all kinds of other problems. But the #1 cause of destroyed batteries and fires is using the improper charger. You have to make sure that you use the right charger, or you're going to have issues. The other problem is overloading the output of the battery. So this is, we're gonna go more in depth in my next video on that. I'm actually gonna show you how to properly wire an 8,000 watt amp or a 5,000 watt amp, because most people do it wrong. So what they'll do is they'll daisy chain one battery to another battery using 0 gauge wire, and then hook up the 8,000 watt amp to the battery in the tour pack. You're overloading this battery. Josh, pass me. Okay, so here we have an 8,000.1 amplifier. If you notice, it has 2 0 gauge power, 2 0 gauge ground. Most people hook this amplifier up wrong. So let's say, for example, these are 2 Harley batteries here. So what they'll do is they'll take a 0 gauge wire from one battery, hook it up to the other battery, and then take a 0 gauge battery from a 0 gauge wire from that battery, then bring it to the amp. So then they'll have power and ground going to this battery, and then the other power and ground going to this battery. The problem with doing it that way is these are 0 gauge inputs. This is an 8,000 watt amp. 0 gauge wire can only handle 300 amps of current. So to make the math easy, let's say it's 100 amps of current for every 1,000 watts. It's really 70, but let's say it's 100 amps of current for every 1,000 watts. So this amplifier technically should have 3 0 gauge power, 3 0 gauge ground, so the amplifier can do 8,000 watts. If you look at the manual on Sound Digital's website, they recommend 00. So it'd be 00 power, 00 ground, 00 power, 00 ground. So then that would technically give you 12,000 watts of current capacity. But in order to do that, you need an adapter that goes from 00 to regular 0. But Sound Digital wrote it in the manual. It's written properly. I have it here. So they want 00, 00, but let's say you only use 0 gauge. The best these batteries can do is 4,000 or 5,000 watts each. So you're supposed to run a power and ground to battery #1, power and ground to battery #2, and then link the 2 batteries together through the fuse block. Also, Sound Digital, if you download the manual, it tells you not to use jumper wires for the batteries. It tells you to use bus bars. All the SPL guys know that already. They'll do a big bank of batteries. And the reason they want you to do bus bars is solid metal can transfer way more current than stranded wire. So they actually want you to do a bus bar between battery #1 and battery #2, then do your 0 gauge power and ground connections to the bus bars. On a bike, that's not always possible because we have one battery in the seat, one battery in the tour pack. So the easiest way to do it, instead of doing a bus bar, would be 1 0 gauge power and ground to the under the seat battery, another 0 gauge power and ground to the tour pack battery, and then you run another 0 gauge power and ground to link the batteries together. Fuses leaving the battery and fuses arriving at the amplifier is the proper way to do it. Nobody does it that way. Let me show you that Sound Digital has a printout that shows you how to properly wire it. So the way on the bottom, you notice there's an X, which is the way everybody does it, where it's 0 gauge jump from battery to battery, and then the last battery going to the amplifier. The problem is, if you're running 0 gauge wire, there's only 300 amps of current that the wire can possibly handle, and then all the load is going out to the first battery, not the second battery, not the third battery. So if you look here, they have bus bars. So the batteries are all linked together to the bus bars. Then the amplifier is connected to the bus bar. So bus bars can handle thousands of amps of current. You hook up your capacitance bank to the bus bar, then the amplifier steals what it needs from the entire bank of current. This is the proper way to do it, and also pay attention to the fusing. There's fuses between the equipment and the bus bars, and there's fuses between the batteries and the bus bars. Whenever people do batteries in the tour pack or batteries underneath the tail, I noticed that there's only one fuse near the equipment, which means the wire is live between the battery and the bike. If you pinch that wire, you could set the bike on fire. It's a pain in the ass doing it this way. It's a lot of extra fuse holders doing it this way, but this is the only proper way to do it. So bus bar. If you don't have bus bars, you have to double up your 0 gauge wires to match up the current capacity for the amplifier. So if you're doing an 8,000, and then I'll get more into this in the next video I'm doing. I saw someone in the tour pack with 1600 amps worth of fusing going through one 0 gauge wire going to the first battery in a chain of batteries. So that means it's a 1600 amp load on just one 0 gauge wire and one battery. Like, that's going to cause problems in the future. This is the proper way to do it. It's a pain in the ass. I know it's a lot more wiring, but this is the safe way to do it, and you'll keep your amplifier from getting destroyed because it gets to pull all the amount of current that it needs. There's a lot of information in the manual. So this is the manual for the Sound Digital 8000.1 Evo X2. It says for 8,000 watts RMS, you need double 0 gauge wire. It's telling you that in order to create 8,000 watts RMS, each one of the amplifier inputs needs double 0 gauge. It's simple math, and it's in the manual. It's showing you, so in this picture, straight from the manual, it's showing both powers and both grounds going to one battery. So you'd say that was wrong, right? This is not on a Harley. So if you go to the other page, it'll show you that the recommended battery is 400 amp hours. So they're recommending a 400 amp hour to run an 8,000 watt amp. So to give you an idea of what a 400 amp hour battery is, it would be 8 of these. It would be 8 of these, because this is a 30 amp hour. So it'd be between 8 and 10 of those batteries. Because these are rated between 30 and 40 amp hours depending on what company. So if it's a 40 amp hour, it would require 10 of these to power one 8000.1 properly. It's not me making this up, and they're saying that's the minimum recommended. So the reason they're showing it like that in the picture is they're assuming that you have one big 400 amp hour battery, and if you have a giant 400 amp hour battery, which would be about the size of the damn table, then you can run both powers and both grounds to one battery. So this is what happens when you improperly charge a battery or you overload the output of the battery. This is what they look like when they don't catch fire. So hope this video helps. If you have any questions, you can reach out to me. Just be safe when you're using these batteries. The technology is stable, but you have to make sure you use the right charger, make sure you store the batteries at the right temperature, make sure you don't overload the battery. So if you go on the battery manufacturer's website, they'll tell you how much output current at burst the battery can give. So I see a lot of people running 12,000 watt amps and 8,000 watt amps. If you're hooking them up, you can't hook them up to a single battery. It's got to be a bank of batteries. But most importantly, 0 gauge wire jumping from battery to battery isn't enough. You have to make sure that you're distributing the amplifier power properly so it's not overloading one single battery. If you do that, the battery could explode and catch fire, and it's not going to be the battery's fault. I'm not going to pick on any shop that I've seen installs from that wasn't done properly. I don't want to damage anybody's reputation, but I will mention some shops that I know are doing it right. So Carl from Hefe is one of the guys doing it right. The reason I bring up Carl is Carl shows all his wiring. A lot of the competition guys hide their wiring. It's their secret sauce. They don't want to show anybody. Carl shows off all his wiring work, and we've talked about this. If he's got an 800 amp worth of load, you see it split across all the batteries. He's always putting bus bars in the tour pack or splitting the 0 gauge runs to the different batteries on the bike, and he always has proper fusing. So I'm going to post a couple pictures of Carl's work, and the owner of the Hulk has, he literally just posted a picture, and the wiring he's holding in his hand is 8/0. So it's 8 0 gauge wires in one. The damn wire is like that thick. So obviously if he's using that kind of wire, he knows he has that kind of current draw, and he knows that single 0 gauge wire is not going to do it. So I give a shout out to both these guys. I know there's a lot of other guys doing it right, but these are two guys that I've able to take pictures from their posts on Facebook because they post it. So I know that they're doing it right, and I've had a conversation with both of them and we agree. This is science, this is not opinion. Like, if you want to do it safely and properly, you just got to follow the laws of science. So that picture was a quick mock-up of a competition bike that we just delivered. So if you notice, there's 3 0 gauge power and 3 0 gauge ground on each battery. We use factory Harley batteries to mock up. That way we wouldn't scratch or damage the limitless lithiums that we ended up installing. So this bike has two 5000s in the tour pack. So we did triple 0 gauge power, triple 0 gauge ground, connecting the two batteries together. And then we did triple 0 gauge power, triple 0 gauge grounds going up to the tour pack where there was another battery where we also did triple 0 gauge power, triple 0 gauge grounds. That way you can flow enough current to do two 5000.1s in the tour pack and two 2000.4s. There was also another battery in the front of the bike. So it was 2 in the tail, 1 in the tour pack, and 1 in the front. We couldn't do bus bars, we didn't have enough space, but to make sure we had 1,000 amps of current carrying capacity, we tripled up the 0 gauge wires. So triple powers, triple grounds to each battery, and then up to the tour pack, and then from that battery to the amplifiers. So I'm gonna post a couple pictures of their work so you can see the way that they do it. And thank you, hope this helps. One more video coming up, and I'm actually gonna show the way that we wire these and the way that we fuse these. Hopefully it helps you guys out there. As you can see, the top third of the case is empty. So you can't judge the size of the battery by the outside case. This case is filled to the very top.